Hello everyone, welcome to the course called Turbo Machines. Before going for the course, I'll introduce myself. Myself Dr. KUMAR, Professor in the Department of Mechanical Engineering, BMS ITM. So today we'll see about the course called Turbo Machines. Before going for the in detailed about the Turbo Machine course, we will see about the syllabus. The syllabus of the Turbo Machine course is as this. It will be having 5 modules. In each module, we will be having 2 chapters. In the first module, first chapter tells about the introduction of turbo machines. In this, we are going to study about what do you mean by turbo machines, how it is classified, what are the different parts of turbo machines, and comparison of turbo machine with some other machines. We'll see all those things along with non-dimensional numbers. And coming to the second chapter in the first module, we will see about thermodynamics of fluid flow, how the thermodynamics is involved or how the fluid is interacting with the machines in terms of thermodynamics. We will see those things in the module 1, second chapter. Coming to the module 2, we will see the energy exchange between the turbo machine. That means how the energy is exchanged between the fluid and the rotary machines. Rotary machines. Those things we are going to see in the module 2. And the module 3 we will see about the steam turbines. I mean, what do you mean by steam turbine, classification of steam turbine, how it is used, how the steam is generated. Then after generating the steam, how the steam is used to generate the electricity that we are going to see here. And method, and also in the steam turbine, we are going to see about what do you mean by compounding, and if the steam is passed to the multiple stages, what will happen, what is the efficiency increases, all those things we'll see in the module 3. And coming to the module 4, it is telling about, it deals about hydraulic turbines, where water is interacting with the rotating machines and how the energy is generated. Those things we'll see here. Again, in all the modules, we'll see about the definition of each turbines, as well as we are going to see about classification, how it is going to work, all those things in each modules. Then coming to the module 5, we are going to study about the centrifugal pumps. I mean to say that how the water is entering to the pump and then how the pump is going to discharge the water to a higher level. Those things we are going to study here along with few numericals. In all the chapters, there will be numericals, and the better textbook for this is an introduction to energy conversion volume 3 turbo machinery, Kadambi and Manohar Prasad, as well as the second textbook where turbines, compressor and fan by SM Yaha. These two are the better textbooks for this turbo machines course. Now we'll switch on to the contents of each module. Now today we'll see about the module 1 first chapter, that is introduction to the turbo machines. Again, I welcome you back for this turbo machines course, where the course title is Turbo Machine and the code is 18ME54. This is the course outcome where at the end of the course the students will be able to classify the typical designs of turbo machines. As I told in the syllabus, the students in all the chapters, first we will deal with the classification of the turbo machines, either to be steam turbine, hydraulic turbine or a pump, like that, and then compare homogeneous machines by using a dimension analysis. And CO2 tells about applying Euler's equation for the turbo machines, and CO3 tells about students are able to analyze the energy transfer in the pump, compressor, turbines on a 1D basis with the use of velocity triangles and conduction of the flip classes, quiz, model demonstration, virtual demonstration. And CO4 tells about the students will be able to evaluate the performance of the turbo machines using different techniques operating under various conditions. This is about a mapping, COPO mapping as well as COPSO mapping. Then we'll go with this turbo machines. What exactly means the turbo machines? The turbo machines means a device, or it is a machine or a device which is in a form of rotary motion. Any rotary equipment, wherever we see, it is considered as a turbo machine, provided it's supposed to be having interaction with the fluid. So I given in short, a turbo machine are the rotary equipment having fluid interaction with it. Wherever we go, wherever we see the rotary equipment having the fluid interaction are considered as turbo machines. So for a few examples I given here, turbines. As we all know that turbines, it has been classified like hydraulic turbine, steam turbine, gas turbine, windmills, all those things are turbines where they are used for generating the powers. Okay. All those are having a rotary motion, as well as the fluid is interacting. In the hydraulic turbine, water is the fluid which is interacting with that, and in the steam turbine, steam is the fluid which is interacting with that, and in the gas turbine, gas is the fluid which is interacting. Similarly, in the windmill, the wind is the fluid which is interacting with the rotary equipment. We will see one by one here. So this is about the gas turbine. How the gas turbine works? The gas turbine is, as the definition tells about, a turbo machine is a rotary equipment. So there is a shaft. Above the shaft there will be a rotor where this is rotating, and the interacting medium is the fluid. Fluid is the air which is entered here. It will get compressed, and with the help of an external combustion source, the gas will get burned off and then energy will be enhanced. Because of that, the turbine rotates and it gets exhausted. So this is how we are going to call, this is because of this only we are going to call gas turbine is a turbo machine. Next example for that is steam turbine, where again the steam turbine, the working principle is same. So steam turbine is also a rotary equipment, but provided here the working fluid or working medium is steam rather than as in the gas turbine, gas is the working medium. In the steam turbine, steam is the working medium. Here you can see how the steam is formed, how the steam is formed from the boiler and it is passed to the turbine, how the electricity is generated. Then the next type of turbo machines is hydraulic turbines. In this, again, as the definition says, this is a rotary equipment. There is a rotary equipment as well as fluid interaction. This fluid is the water. Neither the gas, neither the steam, as we told about the gas and steam turbine. Here, the fluid is water. Next, we'll go with windmill. In the windmill, again, this is considered as a turbo machines. Why? Because it is a rotary equipment where the working medium is the fluid. Fluid is the air. As the air blows over the windmill or the blades of the wind, the vacuum will be created at the back of the windmill, as well as because of the higher pressure at the top end of the blades, the wind try to pull the rotors or the windmill blades so that the energy is generated. Next, coming for this is the application of exact GIF file for the windmill. Centrifugal pump. Again, centrifugal pump may also be called as a turbo machine. All these categories what I shown earlier are power generating turbo machines. Now what I am going to show is power absorbing turbo machines. Here also, as the definition tells, the centrifugal pump is a rotating equipment where the fluid is interacting with that. The interacting fluid is water, so that it is considered as a turbo machine. Next, centrifugal pump. Again, the centrifugal pumps. Just to have a better clarity, I have given two more figures here where the rotating motion is taking place in this equipment and the interacting medium is the fluid. Here it is water. Next, fans. As you all know that fan, this is the one device where air is interacting, where is an interacting medium here, and this is a rotating equipment. The function of this fan is to blow the air. The interacting medium is the air and the rotating element also you can see here. So this is also considered as turbo machine. Where not only the ceiling fan, not only the stable fan, you can also call that PC cooling fans is also considered as turbo machines, because here you can see the rotary motions as well as the fluid interaction. The fluid which is interacting here is air. Next we will see the blowers, where this blower is also considered as a turbo machine, because as the definition tells, if you want to call any equipment as a turbo machine, it should have a rotary equipment or a rotary element and fluid is interacting with that. This is a blower where you can see the air will enter in this, it will compress, so that the compression process of the air will take place with the help of the rotating element and the air will come out from this hose with a higher pressure. This is also a PC cooling, equipment you can see, and you can call it as turbo machine. That is the best example for turbo machines where the air is interacting. You can see that because of the air pressure, the leaves, it is going out. Next, compressor. Compressor is also called as a turbo machines, where because the fluid is a working medium, air is the fluid which is a working medium here, and it is a rotating equipment. So this is also called as turbo machines. So this is also one of the jet engine, where the jet engine, how it propels, because of the air which is entering here, it will get compressed, the burn off, and then energy will be enhanced. Because of that, it will pass through the turbine and the exhaust will take place. So this is also considered as a turbo machine. Instead of calling this gas, we are classified this as gas turbine, steam turbine or hydraulic turbine because of the working fluid. All these are categorized as a power generating machines. All these are categorized as power absorbing machines. We will see that in detail in the further slides. This turbocharger. Everyone has seen that turbocharger used in cars, vehicles, where again the working fluid will be atmospheric air as well as the exhaust gas, and both the fluids will be interacting with the rotating element. That is called turbocharger or a compressor. So it is considered as one of the turbo machines. One of the best example for turbo machines. So here, you can see the better way of this turbocharger, where the fluid is interacting with the rotating element. So that is considered as turbo machine. Only this part is considered as a turbo machine. Next, we will go with application of the turbo machines. Turbo machines can be seen in many applications. I have already shown that, but still more applications I can show here. Turbines, Air coolers are chillers, where again air coolers or chillers are a rotating element where the air is an interacting medium. Jet engines, ship, marine. In the ship, I think probably you can see at the bottom of the ship there will be a propeller. The propeller is rotating and the interacting medium is the water. So as the definition says, a turbo machine must be having a rotating element as well as a interacting medium as a fluid. Again in the ship, interacting medium is a fluid which is water as well as the rotating element called as propeller. And the marine, aircrafts, oil mills, these are all the few applications of turbo machines, where you can see the turbo machines in these applications. Along with this, many more applications also you can see. Now come for the definition of turbo machine. A turbo machine is a device. In the previous slides, I told about the turbo machine in a short manner, but now we'll go in detail for the exam point of view. A turbo machine is a device in which energy transfer takes place between the flowing fluid. I'll concentrate here more because flowing fluid is very important term in the turbo machine chapter. And the rotating element due to the dynamic action and results in the change of pressure and momentum of the fluid. So in this, the key word I highlighted here, the flowing fluid, rotating element, dynamic action, change of pressure and momentum. This is the definition of turbo machine. Classification of turbo machines. Turbo machines are generally classified as two types. One is power generating turbo machine, power absorbing turbo machine. As the name indicates, power generating turbo machines are the devices where used for generating the power. As earlier discussed about the turbine, windmill, gas turbine, hydraulic turbine, steam turbine, all these categories will come and be picked in the power generating machines. Power absorbing machines are those machines which interacts with the fluid, but it is going to absorb the electricity to interact with the fluid and the energy will be given to the fluid. In this power generating machine, energy of the fluid is taken to generate the power. In the power absorbing machines, electricity is taken to enhance the fluid power. For example, centrifugal pump, blower, fan, compressor, etc. We will see in the next slide in detail about those things. Power generating machines. The other name for power generating machines is the power developing machines, okay, or power developing turbo machines. In this, what will happen? Energy of the flowing fluid in the power generating machines, energy of the flowing fluid is used for the rotation of the impellers or the blades or the buckets or the wings or the rotor. So I given the different names for the rotor. In some of the machines it is called as an impeller, in some of the machines it is called as a blade, buckets and a wing. You can see the fan, which is a rotating element. In the fan, the rotating element is the blades. So we are going to call it as a blade. That is nothing but a rotor. We can call it as a rotor. In the ship, the rotating elements are propellers. The same blades, we are going to name it as a propeller. In the windmill, we are going to call it as a wings. Like that, different names are given for different turbo machines. The different names are given for the rotors, which are used for different turbo machines or different applications. Okay. The example for power generating turbo machines are steam turbine, hydraulic turbine, wind turbine, and the gas turbine. Or you can say as windmill and a gas turbine. Where in all these applications or examples, whatever I showed, there will be a rotating element and there will be a fluid which is interacting. In the steam turbine, steam is a interacting fluid. In the hydraulic turbine, water is an interacting fluid. And in the wind turbine, air is an interacting fluid. And in the gas turbine, gas is an interacting fluid. Another way, the higher energy air is an interacting fluid. So based on the definition itself, all these are classified. Now, this is an example for hydraulic turbine. In the steam turbine, the steam enters and it hits the buckets, or it is also called as a blades. The steam hits the blades or a vane. Depending upon the application, we will name it in a different way. For instance, we will call it as a rotor. The steam hits the rotor and the rotor starts rotating. As a basic definition, I already explained that to call any machine as a turbo machine, there should be a rotating element and a fluid interaction. So here the wheel or a rotor is rotating and the fluid, which is called as a steam, hitting the blades or the rotor. Because of that, the rotor starts rotating. Working medium is the steam and rotating element is this rotor. So combination of these two, we can call it as turbo machine. Or in generally, because as a input fluid is a steam, we are going to call it as steam turbine. Next, we'll go with the next example called hydraulic turbine. Here also, there is a working fluid and a rotating element. Combination of these two is called as a turbo machine. Any machine which is having a rotary motion due to the interaction of the fluid is considered as turbo machine. So here, this is called as a rotor. runner or a bucket where the water hits the rotor and it starts rotating. As the interacting fluid is water, we are going to call this as hydraulic turbine. Here as a interacting fluid is steam, we are going to call this as a steam turbine. Here this is a hydraulic turbine. The next example is windmill. Again here also you can see the rotating element and the air which blows over the blades. So interacting fluid is air and this is a rotating element. Combination of these two we can consider as turbo machines. The next example is the gas turbine, where the gas will enter the blades, it starts rotating and it gets exhausted. So all these are the best example for power generating machines with the help of different nature of fluid, different fluids. Steam is the fluid, water is the fluid, air is the fluid, gas is the fluid. So I can take one example each. Next classification is power generating machine. Now we have completed power generating machine. We'll go with power absorbing machines. We'll see the examples for power absorbing machines. The power absorbing machines are one which absorbs the power and uses that power to enhance the energy of the fluid. Either it may be air, gas or water. This is called a centrifugal compressor, where we are going to supply the power for this. Because of the supplying of the power, this rotor starts rotating. Because of the rotor starts rotating, vacuum creates and the water from the lower level will enter to this, and the energy will be enhanced to the water because of the centrifugal force, and the water will be discharged to higher level. So it is considered as rotating element. This is called as turbo machine. The second example is again centrifugal pump, where the water enters here. Because of the centrifugal force because of the rotary motion of the rotor, the centrifugal force will be transferred to increase the fluid energy, and then higher energy will get at the output. The next example is the fan. Again, this is a power absorbing machine because we are going to supply the electricity to this. Because of that, the blades of the fan starts rotating. Because the blades of the fan starts rotating, air gets circulated. The energy, it will throw the air with a higher pressure. So it is considered as a turbo machine. This is an example for power absorbing machines. Next topic we'll go with the components of the turbo machine. So now we understood about what you mean by turbo machines, how it is classified. Before going for this, I'll repeat the concept. Turbo machine is a device which uses the rotary component, or if any devices interacting with the fluid with the rotary equipment is considered as a turbo machine. Okay. And how it is classified? It is classified into two types. One is power generating machine, one is power absorbing machines. In power generating machines, the energy is produced because of the flowing fluid. In power absorbing machines, because of the energy supplied to the rotor, the fluid power is enhanced. Okay. Now we'll see about the components of the turbo machines. Components means different parts, important parts of the turbo machines. You can draw any example, you can take any example for the components of turbo machines. What are the different components mandatory it should have? It should have rotor and the fluid flowing. These two. These two are the important or the mandatory component to call any device as a turbo machine. Here I have taken the example of this, where the fluid is flowing. Because of the flowing fluid, the turbine starts rotating. You can see that expanded view of this, the same figure, expanded view you can see here. Okay. Where the fluid is interacting, because of the fluid flow, the turbine or the rotor starts rotating. So it is called as turbo machine. Okay. In this, what are the different parts? Two parts we have, only one part we have studied now, that is rotor. Now we'll see, because I concentrated more on the rotor till now because it is a mandatory part. And there are some parts which are not mandatory for all the turbo machines. We'll see further. For the exam point of view, this is a figure what is expected to draw. You can draw any figure like a fan, pump, turbine, blower, anything you can draw, which should consist of rotor blades and it should show the fluid flow, direction of the fluid flow. That's all. But this figure also holds good, where it includes all the parts which are not mandatory. Only mandatory part is the rotor and the flowing fluid. Here we are having so many parts called as a rotor, stator blades, casing, shaft and the exit, along with the inlet. So these are all the different parts of or components of turbo machines. In this, all components are not mandatory for all turbo machines. Say for example, casing. Casing is not so important for the fan. There is no casing for the fan. Directly there is a rotor and air is interacting. Like that. Depending upon the application, some parts will be eliminated and some part will be retain. So what is the mandatory part in all the turbo machine? The mandatory part in all the turbo machine is the rotor and the flowing fluid. The direction, you should supposed to show the direction of the flowing fluid in the rotor. Okay. Now we'll see the components. First component is rotating element, or the other name is rotor. It is a mandatory part for all the turbo machines. In this rotor, what will happen? Energy transfer occurs between the flowing fluid and the rotating element due to the momentum change between fluid as well as the rotor. And it is a mandatory part. The name of the rotor, depending upon the application or depending upon the devices, we are going to name it with the different names. Vanes, rotor is called as vanes, blades, buckets, impellers, propellers. So for example, buckets. Rotor is called as a buckets in the impulse turbine, that is Pelton wheel turbine. Impellers in the centrifugal pumps, propellers in the Kaplan turbine, blades in the windmills as well as the fan, vanes in the centrifugal pump or the Francis turbine. Like that, depending upon the name of the devices, we are going to call the rotor in the different names. The next important part is not so important or mandatory, but it is required for few components, few of the turbo machines. I'll give you example of that turbo machines. The name of the stator is called as stationary element. The name of the stator is called as a stationary element or fixed element or the nozzle. You can see. What is the function of a stationary element? The function of a stationary element is to guide the fluid to flow in which, it tells about the fluid to flow in which direction, in what direction the fluid has to flow. So it will guide. So it is called as a guide blade, fixed blade, stationary element or the fixed element, nozzle. There are so many names for the guide blades, which helps in efficient energy conversion process. Control of the fluid can be easily, the fluid flow can be controlled easily with the help of the guide blades. And the third part is the shaft. The shaft is the one which is important part, as same as the rotor. In some of the machines, we are going to couple these two. Rotor is coupled directly to the shaft. There will be shaft. Above the shaft, the rotor is coupled directly. Okay. This shaft always used to transmit the power. Always used to transmit the power. And the shafts are classified in two types. One is power generating shaft. One is power absorbing shaft. That again, the classification depends upon where we are going to use the shaft. The shaft is nothing but a circular rod. If it is connected to a turbine, it is called as power generating shaft. If the same shaft is connected to the fan, it is called as power absorbing shaft because it is going to absorb the power. The next part is casing, or other name is housing. What is the purpose of a casing or housing? It keeps all the component within the specified space. So it is called as casing or an housing. Okay. The fluid will also be within the specified space and it is not mandatory for all the machines. Again, I will come back for the figure so that all these components you can understand with the figure easily now. Rotor, mandatory part which rotates because of the fluid flow. Shaft which is connected to the rotor, and this shaft may be different. It may be called as power generating shaft or power absorbing shaft, and this is called stator blades which guides the fluid flow. See the fluid will enter here, it will try to push the rotor blades, and then the turbo machine, the rotor starts rotating and the air has to go in particular direction. So the stator blade is also called as a guide blade. It guides the air to move in which direction. See, there is a space given. In that particular space, the air will pass and again it will get exited. So that is the function of a stator blade, and the stator blade is not mandatory for all the machines. The casing. Casing is used to keep all the component well within the specified space as well as to allow the fluid to flow in particular direction. So these are all the components of turbo machines. Now we'll go for the next topic called as classification of turbo machines. How turbo machines are classified? Turbo machines are classified by this time, I think probably you got some idea about how turbo machines are classified. It is based on energy transfer, that is power absorbing, power generating. So there are still more classification we can see further here. Based on energy transfer. How it is classified? Power generating machines. What are the power generating machines? Power generating machines are the devices those devices which generates the electricity or a power. All turbines I can put here. I am not named here. Simply I have given us all turbines. That means it may be steam turbine, gas turbine, hydraulic turbine, windmill, everything will come into picture here for power generating machines. So this slide shows you one of the example for power generating machine. The working fluid is water, so it is called as hydraulic turbine. Next example is Francis turbine. Again the water is a working fluid. Because of the flowing of the water, the turbine blade starts rotating, power generates. This is power generating turbo machines. Next is steam turbine, where the steam is used as a working fluid. Because of the steam, the turbine starts rotating, and then this is called power generates. So this is also categorized as power generating turbo machines. Next is windmill, where the air will flows over the blade and the blade starts rotating, energy generates. So it comes under power generating turbo machines. Next is the gas turbines, where as you can see in the jet engines, air is a working medium which enters and get higher energy, and that the higher energy of the air is transferred to the turbine. Because of that, energy is generated. Here we are not going to produce the electricity directly, but still it is considered as power generating machine. If we couple the shaft to the generator, it generates the electricity. Here in the jet engine, it is used for propelling the jets. Next is power absorbing machines. Examples are pump, compressor, fan, blower, vacuum cleaner. So many examples you can give, but provided there should be a rotating element and there should be a fluid. I give a few examples here. One is the centrifugal pump. See, there is a rotating element, water is a fluid which is interacting. Because we are giving a power to this, once the electricity is supplied to the centrifugal pump, it starts rotating. Because of the rotating of the centrifugal pump, vacuum is created and the water is entered to this. And because of the centrifugal force, the energy of the water is enhanced and it is trying to push or deliver to the higher level. So this comes under category of power absorbing machines. Next example is fan. For this fan, we are going to supply the electricity. Because of the electricity what we have supplied, the blades starts rotating and it tries to throw the air outside. So air is a working fluid as well as the rotating element is the blades. And this blade is rotating not because of the air, this is rotating because of the power supply. So it is called power absorbing machines. Next is the blower, where again the blower working medium is air. How it is rotating? We are going to supply the electricity for the motor starts rotating, vacuum creates, air enters here, and it is going, the centrifugal force of the rotor is converted to the higher pressure, the pressure energy of the air, and then it is thrown, the air is thrown away from the blowers. So it is called power absorbing machines. Next is power transmitting machines. This is I not explained till now. Power transmitting devices are those devices which is used to only transfer the power with the help of the fluids. The best example is the fluid couplings. You can see this in our transportation sectors. We will not deal much about this power transmitting devices in this course. We are going to completely deal about only power generating devices and power absorbing devices. Next classification is based on direction of the flow. Till now we have not discussed about the direction of the flow. Now we will see about the direction of the flow. Okay. With reference to the axis. See here, this is considering the axis is at the center and the fluid is flowing. The fluid is flowing along with the axis. So it is called as axial flow. Axial flow. Depending upon the fluid flow along with the axis, based on the arrangement of the fluid as well as axis, we are going to name as axial flow machines, radial flow machines, mixed flow machines. We will see further. The best example for the axial flow machine is axial pump, windmill, Kaplan turbine. These are all the examples for axial flow machine. The key or a buzzword to remember for the axial flow machine is, if the fluid is flowing along the axis of the rotor, it is considered as axial flow machines. Next is radial flow machines. It rotates radially. If let us assume this is a shaft, and if the water flows radially around the shaft, it is considered as radial flow machines. Better example for that is centrifugal pump, compressor, Francis turbine. See here, the fluid enters here. It starts rotating along with this is the shaft. It starts rotating along with the radial direction of the shaft and it is going to up. The fluid is going up. So this is called as radial flow machine. Next is tangential flow machine. If the rotor is rotating like this, water neither enters like this, neither enters along with the periphery. The water enters tangentially. For example, if this is a rotor, if the water hits only in the tangential direction, that is called tangential flow direction, tangential flow turbo machine. Example for that is Pelton wind turbine. So this is the rotor, water hits tangentially. If this is a shaft, considering the shaft, the water always try to move tangentially to the shaft. So it is called as tangential flow turbo machine. Axial flow, radial flow and tangential flow. Next we will go with mixed flow. In the mixed flow turbo machine, we can see both axial as well as radial direction. So this is again the mixed flow direction. water enters radially and leaves axially. So this is an example for mixed flow turbine. That better example you can see, the better working of mixed flow you can see here. Water enters like this, it will occupy the space radially, it leaves like this. So this is called, if you cut the machine here and if you concentrate only on the water entry here and water exit, you can observe the mixed flow direction, how it is taking place. The third example is based on position of the shaft, how the shafts are positioned. Horizontal shaft, if the shaft is kept horizontally, it is called as horizontal shaft. The better example for the horizontal shaft turbo machines are steam turbines, centrifugal pump, windmill, all those are horizontally. In all the machines, shafts are placed horizontally. Vertical shaft, that means if the shaft is kept vertically, those things are considered as vertical shaft turbo machines. In Kaplan turbine, we can see the shaft which is vertical. And in the fan, the shaft is kept vertically, in the ceiling fan. So, those are all the example for vertical turbo machines, vertical shaft turbo machines. The next is inclined shaft. If the two shafts are neither in parallel, nor in perpendicular or mixed, we are going to consider this as inclined shaft. The best example is modern bulk micro hydro turbines. These are all the turbo machines, how it is classified based on the shaft position. Next is based on the condition of the fluid flow. There are two conditions. One is impulse force, reaction force. Impulse force is nothing but sudden heating force. If water or a steam or a gas is coming and hitting the blades and the blade starts rotating, it is called impulse turbine. And because of the reaction force, if the water or a fluid or air rubs over the surface, because of the rubbing action, the blade starts rotating. That is considered as reaction turbine. The best example for the impulse turbine is Pelton wheel, D-level turbine, Curtis turbine. These three are the turbines which are best example for the impulse turbine. And for the reaction turbine, Francis turbine, compressor, Parsons turbine are the best example for reaction turbines. We will study in detail about the working principle of Pelton, D-level, Curtis, everything in the further classes. Okay. This is the best analogy to explain about the reaction force and the impulse force. Thank you.